Hello, welcome back. So in the previous video, we have discussed the cold alkaline KMnO4 reactions of alkenes. So now we have covered all the very important properties of alkenes, the chemical properties, which are very important reactions. Now let us speedrun all together and let's cover the reactions which we have missed. So the first one we have discussed was hydrohalogenation reaction. So hydrohalogenation reaction is nothing but addition of HX. So HX is added. Now it follows two rules, that is Markovnikov rule and anti-Markovnikov rule. Markovnikov rule is when unsymmetrical alkane, so H plus adds where there is more number of hydrogens. Anti-Markovnikov rule comes under only when HBr is acting in presence of peroxide. It's called peroxide effect or Karash effect. Okay, so anti-Markovnikov effect is H plus attacks where there is less number of hydrogens. Okay, that's anti-Markovnikov addition. Now, the second reaction is addition of H2SO4. Okay, now let's discuss this in detail. You take alkene and then you are going to react it with dilute H2SO4. Okay, dilute H2SO4. Now, what would happen? This is the forming one. This double bond is going to break, and then one hydrogen is formed. Number two, O SO3 H is formed. SO3H. Okay, this is called alkyl hydrogen sulfate. And then you are going to heat it in presence of water. Hence, alcohol is formed. Okay, so alcohol is formed because of addition of H2SO4 and thus heating it. So here clearly Markovnikov addition takes place. That is the important point we have to grasp. Okay. Now here CH2 double bond CH2. If you react it with H2SO4 and H2O, then OH is formed. Of course. Now Markovnikov addition means where there is more number of hydrogens, the hydrogen goes and attacks here. Means the hydrogen first went and attacked here because here there are more number of hydrogens, and then what is the next? OCO3H, but it OSO3H, but it is going to we are heating it, then OH is formed. Okay, so this will be the answer. Now, addition of water is the third reaction. Addition of water is adding water, just simple. So, and we are going to need some H plus ions. So, we are going to add minute drops of dilute H2SO4 because you need H plus ions for the reaction. So, from concentrated H2SO4. So, from concentrated acid, we are going to need H plus and add H2SO4. So, because of this, a tertiary alcohol is formed. Okay, why? Because whenever you are going to do reaction with water, mechanism we are going to see. Now CH3, CH3, C plus CH2, CH, like first H plus goes and attacks this side. So this will take the electrons. So this will get a negative charge. This will get a positive charge. Okay, immediately H plus goes and attacks here. Okay, so again because of water, what would happen? This O H H. This center is attracted to this positive charge. Okay. So what would happen? H plus is released by giving of this bond, and thus OH is formed and H plus is released. And this H plus which is released is again utilized for the reaction furthermore. Okay. So alcohol is formed. Here we can even rearrange the carbocation by hydride shift or methyl shift or whatever you want to do. We have seen ring expansion also. Okay, so questions might be tricky on this question. So this concept, so be careful. Now we have seen oxymercuration, demercuration. Oxymercuration, demercuration is very simple. Where you first add mercuric acid in presence of water and THF, and then a hydroxyalkyl mercury compound is formed. This step is called oxymercuration, and then you are going to add NaBH4 and OH minus, so that this is released and a H is replaced. Okay, so this is and hence alcohol is formed, and in oxymercuration, demercuration, 100% Markovnikov product is formed. We have discussed all the mechanism in the detailed video. You can go and check it in the hydrocarbons playlist. Now, hydroboration followed by oxidation. This also we have discussed very detailedly. So here, what happens? Alkene is reacted with B2H6 or diborane, and trialkyl borane is formed like this BRR. So later, when you are going to react it with H2O2, Then what would happen? Slowly 3 ROH is formed, and then BOH thrice is formed. So three alcohols are formed. Okay, and the alcohols are anti-Markovnikov addition. Means where there are less number of hydrogen goes and attacks there. Okay, so that is hydroboration followed by oxidation. The mechanism is you can just read this, or you can even see the video which we have explained in great detail. Now, halogenation reaction. So halogenation of alkenes. We have seen halogenation of alkenes, bromination. So let's see halogenation in alkenes. So you take alkene, add uh, halogen. So using CCl4 or CH2Cl2, you can use anything. Just alkene is broken and halogen is added like this. So in halogenation, very important, only anti-addition takes place. Only anti-addition takes place. That is the point we have to remember. Means the groups are added from the opposite side. What's the mechanism? So Br, what happens is the two electrons which are going to be on Br, they are going to form a transition state like this, and then the double bond is first affixed to bromine, and then another bond is affixed to CH. So positive charge is formed. So this is called cyclic halonium ion. Now Br minus, which is already there in the solution. Okay, Br minus, which is already there in the solution, it attacks on the ring. So this Br plus is unstable, right? Br is electronegative element and again positive charge, it's not looking good. So Br will attach from the opposite side. So this bond is broken, and then this Br minus is going to come and attack the open ring. So that is why anti-addition takes place. So halogenation of alkenes is anti-addition, which we have to remember. Okay, ozone-Alsace reaction we also discussed in great detail. So you take alkene and then you are going to react it with ozone. Ozonide is formed. Ozonide is highly unstable. So reducing agent and oxidizing agents are going to act on it. So when you are going to use reducing agents, two carbonyl compounds are formed, which can be two ketones or two aldehydes or one ketone, one aldehyde. Okay, and then oxidative ozone also means there also first ketone aldehydes are formed. Ketones cannot be oxidized, but aldehydes can be oxidized. So aldehydes are oxidized into carboxylic acids. Okay, so ozonide is formed. And when you are going to use reducing agents, what are the famous reducing agents? These are the famous reducing agents. Zinc is majorly used, and zinc in presence of AgOC, AgOH, sorry, AgOC only. AgOC, sorry, ACO minus. So in case of that reducing agent, ozonide is going to form two carbonyl compounds. So the short trick is break the double bond, put double bond or double bond. Okay, cut the double bond, put double bond or double bond. And in case of oxidative ozonolysis, first these are forms and then oxidation takes place. Oxidation of ketones is not possible, so that is why aldehydes are going to oxidize. So and where there is hydrogen, just insert an oxygen between them. So OH will form. C double bond OH is carboxylic acid. Done. So you're not going to miss a single question on ozonolysis. And ozonolysis helps in identification of double bond, where the double bond is present in the compound. And there is an important note in preparation of alcohols. So whenever you are going to get carbonyl compounds, you are going to reduce them using LiAlH4 or NaBH4. Then alcohols are formed. You can see here C double bond O. When you are going to use this reagents, uh, this bond is broken and H plus is going to come and attack OH. And similarly, you can see for ketones also. Okay, next we have hydroxylation. We have discussed this also in very great detail. So a cold alkaline KMNO4 is called Bayer's reagent. So in Bayer's reagent, diols are formed and syn addition takes place. In Bayer's reagent, OSO4 in pyridine and I2 NaOH, syn addition takes place where peroxy formic acid, or in any peroxy acid. What is peroxy acid? Where double bond O bond is there. Okay, it's called peroxy acid. So in every peroxy acid case, anti-addition takes place. Whenever peroxy and stuff are there, anti takes place. Okay, you remember like that. So OSO4 in case of pyridine, syn addition important, and then cold alkaline KMnO4, Bayer's reagent, syn addition, and MnO2 is formed. And important thing to remember, MnO2 is brown in color, so we can test if it's alkene or not by reacting it with KMnO4, and brown color solute tells us that it is alkene. So Resmic and Miso we have discussed. So car is the shortcut. To see this shortcut, go and visit that video, a separate video on KMnO4 reactions. Okay, it was a really nice video. It turned out really good. So go check it. So, test for unsaturation. Whenever KMnO4, you are going to react. KMnO4, the solution first, it is purple in color. As I said, MnO2, brown color is formed. It helps in identification of alkene. It is test for unsaturation. Another test of unsaturation is with Br2 water, bromine water. So, brown or deep red color, it will turn colorless by addition of alkene. Okay, these are tests of unsaturation. And then with hot alkaline KMnO4, oxidative cleavage means high oxidation takes place. If terminal alkene is there, it will turn into CO2. If middle alkene is there, it will turn into double bond O and OH. And if it is a 3 degree scenario, then only double bond is formed. You have to remember this. It is very important. So any question is there, if it is a terminal alkene, convert it into CO2. If it is a middle alkene, convert it into OH. Convert it into double bond O. And if it is a 3 degree scenario, then convert it into double bond O. Okay. And epoxidation reaction. Okay. Uh, so epoxidation reaction, here what would happen is you are going to take alkene and you are going to react it with some peracid. What is peracid? We just saw something with OO bond. Okay, OOH. Then anti-addition takes place. We have discussed before. So because of this reaction, examples are this performic acid type of thing and MCPBA also. Right. So anti-addition takes place and cyclic ethers are formed. It is very important. Okay, just give me a minute. Right. Now, addition of methylene. So you are going to take alkene and then react it with CH2N2. So whenever you are going to see such kind of compounds, important thing, carbenes are formed. What are carbenes? 6 electron carbon system are called carbenes. And then see here you can clearly see 6 electron system is there. So C 1 2 3 4 5 6. So 6 electrons are there. So this carbene is going to react it with this alkene. So carbene is going to react with alkene and then this cyclic compound is formed. A cycloalkane is formed because of carbenes. It is important and the reagent we are going to use is CH2N2 and it forms carbenes in presence of sunlight. Huh. Now we have Simmons-Smith reaction. Okay, Simmons-Smith reaction is also something like this. It is related to carbenes only. Okay, here also carbenes are formed. So what would happen? Here the reagent is CH2I2 and zinc copper couple. We have seen this a couple of times. So this is only Simmons-Smith reaction. So instead of CH2N2, we are going to use CH2I2. Here also carbene is formed and the byproduct will be ZnI2. Okay, and then copper is also formed. This is important because it's a named reaction and we are going to come across this many times. And we have a very chindi reaction after this, Diels-Alder reaction. So what is Diels-Alder reaction? Here also an alkene form reacts with a diene. Okay, you can see in the mechanism the double bonds keep exchanging, a new bond is formed between this. Why is this happening? Because there is a possibility of a six-membered ring and six-membered rings are stable. Bayer strain theory. So these are the reaction 4 plus 2 cycloaddition means 2 carbon compound and 4 carbon compound are going to mix and form a cyclo compound. This addition is called Diels-Alder reaction. Very important reaction. We are going to come across this many times. So in heat, in presence of heat, this will be the transition complex and this will be the compound formed. Okay. So this is part one of all the properties of alkenes. In part two, let us see allylic hydrogenation and polymerization reactions. Right? Thank you. Have a nice day. Do not forget to revise all the reactions. Thank you.